Hello and welcome to this video on generating quadratic sequences. If you haven't already done so, please go and check out generating linear sequences. Linear sequences are a bit easier than quadratic ones, and if you can't do a linear one, then you certainly won't be able to do a quadratic one. So if you haven't done so already, check out that video first and then come back. Right, assuming you're ready then, this is a quadratic sequence in its nth term form. The way to tell it's a quadratic sequence is because of this term here, the n squared. Any sequence where there's an n squared as the highest power is a quadratic one. If there isn't an n squared there, and this was gone, and we would just have this 6n minus 2, that's one of the linear sequences from the other video. So the presence of this x squared makes it a quadratic sequence. So the way you generate it is exactly the same as how you generate a linear one. To get the first term, you substitute n as 1, the second term n as 2, and so on and so on. So let's get the first term by substituting n as 1. So for the first one, we're going to have 1 squared, because it's n squared, plus 6 times 1, and then subtract 2. And we work all that out. We've got 1 squared, we add 6, then we take away 2, we end up with 5. For the second term, we're going to do 2 squared this time, plus 6 lots of 2, and then take away 2 again, and that comes out as 14, because we've got 2 squared is 4, 6 times 2 is 12, and then take away 2. And the third one, this time we substitute 3, so 3 squared plus 6 lots of 3, take away 2 again, and when you do this one you get 25. For the fourth term, we're going to do 4 squared plus 6 lots of 4 this time, and then take away 2. And when you work all that out, you should get 38. And the fifth term, we've got 5 squared plus 6 lots of 5, and then take away 2, and for that one you should get 53. So this sequence goes 5, 14, 25, 38, and 53. Now there is one fairly common error that we tend to see, and that's to do with the squared number here. So if we take 5 squared as an example, 5 squared is equal to 5 times 5, which is 25. Some people unfortunately confuse 5 squared with 5 times 2 and get 10, which is incorrect. So 5 squared is 25 because you multiply 5 by itself, whereas this one, people have gone 5 times 2 and end up with 10. That's one of the main reasons you might get a question like this wrong. So similarly, 4 squared here is 4 times 4, 16, not 4 times 2, which gives you 8. That's incorrect. Okay, here are 2 questions for you to have a go at then. So press pause, have a go at these yourself, and then press play and I'll tell you what the answers were. Okay, for this first one we wanted to do 1 squared plus 3 lots of 1 plus 5, then 2 squared plus 3 lots of 2 plus 5, 3 squared plus 3 lots of 3 plus 5, 4 squared plus 3 lots of 4 plus 5 again, and finally 5 squared plus 3 lots of 5, then add 5. And the numbers for these, you should be getting 9, 15, 23, 33, and 45. For this second one, similar idea. So we've got 1 squared. We've got to be really careful here. You've got to subtract 3 lots of 1, not add, plus 1. We've got 2 squared, subtract 3 lots of 2, plus 1. 3 squared, subtract 3 lots of 3, plus 1. 4 squared, subtract 3 lots of 4, plus 1. And finally 5 squared, subtract 3 lots of 5, plus 1. This one, now you've got to be really careful and make sure you're paying attention to this negative here. So you should get negative 1 for both of the first 2 terms. Then you should get 1 and 5 and 11, like this. So again, being very careful that these negatives. So that first one there is 1 squared, that's 1. Take away 3, that would put us on negative 2. And then add 1, that would put us on to negative 1. Okay, here's a slightly harder example then. The difference here being this number. You'd call this number the coefficient of n squared. It's the number that's in front of n squared. Previously there wasn't one here. It was effectively a number 1. Now we've got a 2, and it could be any number here, and we've still got to deal with that. It makes one slight change to the method, but hopefully it's not too difficult. So for the first term here, rather than just doing 1 squared, we're going to do 2 lots of 1 squared. And then we're going to add 6 lots of 1 as before, and then take away 2. Then we're going to do 2 lots of 2 squared, plus 6 lots of 2, take away 2, then 2 lots of 3 squared. So you can see that all this 2 at the front does is means whatever we get when we square these, we simply double it. So we're going to do 2 lots of 4 squared for this one, plus 6 lots of 4, and take away 2. And for the final one, 2 lots of 5 squared, plus 6 lots of 5, take away 2. Now, when calculating these values, you have to be really careful and make sure that you square this number before you multiply it by 2. So this one here, we do 1 squared, and then double it, that would be 2. Add our 6 lots of 1s, and then take away 2, and you'd end up with 6. This next one, you do 2 squared, which is 4, double that to get 8, add 2 6s, that's 12, take away a 2, and you'll end up with 18. So this next one here, you can really see the mistake. Some people would do 2 times 3, which is 6, and then square it and do 6 squared, which is 36. That's incorrect. You need to do 3 squared first, which is 9, and double that to get 18. So filling in the rest of the numbers here, you would get 34, 54, and 78. But that's certainly a mistake to watch out for. Make sure you square all of these, then double it. So the sequence goes 6, 18, 34, 54, and 78. So here are 2 more just like that with a coefficient. So for this one, remember to do 3 lots of n squared, and this one 5 lots of n squared, but you do the squared bit first before you multiply by this number here, the coefficient. So press pause and have a go at these 2, and then when you want the answers, press play and I'll tell you what they were. Okay, here are the answers to these ones then. So you've got 3 lots of 1 squared, plus this one's interesting because the coefficient of n is just 1, so it's going to just be plus 1, then plus 1. 3 lots of 2 squared, plus 2, plus 1. 3 lots of 3 squared, plus 3, plus 1. 3 lots of 4 squared, plus 4, plus 1. And then finally 3 lots of 5 squared, plus 5, plus 1. If you calculate all of these, then you should be getting 5, 15, 31, 53, and finally 81. So the second one here, we've got 5 lots of 1 squared plus 3 lots of 1, so we do have a coefficient of n this time, then take away 4. Then we've got 5 lots of 2 squared plus 3 lots of 2, take away 4. 5 lots of 3 squared plus 3 lots of 3, take away 4. And then 5 lots of 4 squared plus 3 lots of 4, take away 4, and then finally 5 lots of 5 squared plus 3 lots of 5, take away 4. And if you work each of these out, then in some cases here you get some quite big numbers. The first one there is 4, then 22, then 50, 88, and finally, well done if you got this one, 136. Okay, there's only one other type of question that we need to look at for generating quadratic sequences, and it's something like this. Generate the 9th term of the sequence with nth term, 2n squared plus 4n plus 1. So this time, rather than generating all 5 of the first 5, we just asked specifically for the 9th term. We must get the 9th one and no others. So in exactly the same way, we're going to substitute in a number, but to get the 9th term, surprise, surprise, you substitute in 9. So we need to do 2 lots of 9 squared plus 4 lots of 9, and then add 1 to that. So 9 squared is 81, so we're going to do 281s, which is 162, plus 4 9s, which is 36, and then add 1 to that. If you do all of that, you should get the answer 199. So it doesn't matter what term they ask for. They could ask for the 7th term, the 20th term, the 10th term, the 100th term, any number, whatever that is, you substitute it in to generate that term. So here are 2 for you to go at then. You've got the 10th term for this sequence and the 15th term for this one. So press pause, have a go at these yourself, and then press play and I'll tell you what they were. Okay, here are the answers then. So for this first one, you should do 3 lots of 10 squared plus 8 lots of 10, subtract 14, and 10 squared is 100, times that by 3 is 300, plus 80, and then take 14, and all of that comes to 366. And for this one, we've got 5 lots of 15 squared minus 2 lots of 15 plus 12, Well, 15 squared is 225, so if you do 5 lots of 225, you're going to get 1125. Take away 30, add 12, and that comes out as 1107. That completes this video on generating quadratic sequences. Be sure to check out the next video in this series, finding the nth term of a quadratic sequence.